Welcome. In this course, you'll build a solid foundation in PKI and certificates, then apply it using Microsoft ADCS in a real lab. We'll secure TLS, RDP, users, and devices, so you can design, run, and troubleshoot an enterprise-ready hybrid PKI. We'll begin with PKI and cryptography basics, then quickly move into building an Azure lab and an enterprise CA. From there, we'll apply PKI to real enterprise scenarios, and wrap up with troubleshooting, security hardening, and hybrid integration. Think of your PKI skills as a staircase. First, you'll see how trust and validation actually work, so later problems make sense. Next, we design the lab and make architecture decisions before we ever install a CA. Only then do we deploy, issue certificates, and operate real services. After that, we focus on troubleshooting, and finally on hardening and governance, so your PKI is secure, reliable, and supportable. You can treat this course as both a path and a toolbox. If you're new, start at the beginning and do every lab. Later modules assume that foundation. If you're intermediate, skim what you know, but slow down for design, templates, revocation, and troubleshooting. If you're advanced, you can head straight into hardening, governance, and hybrid scenarios. Whatever your level, pause to inspect configs, repeat labs, keep notes, and ask focused questions with screenshots and exact errors. In this topic, we'll build a clear mental model of PKI. Think of PKI as the system that answers "Who are you?" and "Should I trust this connection?" for servers, users, and devices. We'll connect that idea to everyday certificate uses, then see how Microsoft ADCS plugs into Active Directory to provide those certificates. Picture a digital certificate like a passport for computers and applications. When your browser talks to a website, it needs more than a password. It needs proof the server is real and not an imposter. A certificate binds identity information to a cryptographic key, and it's vouched for by a certificate authority. Because everyone trusts that authority, they can safely trust the certificate and build encrypted, authenticated connections. PKI's core job is to answer one question: who am I really talking to? A certificate binds an identity to a key pair, and the certificate authority vouches for that binding. When a machine presents its certificate, other systems can verify it through the trust chain instead of relying on shared passwords. That's how servers, laptops, VPN clients, Wi-Fi, and internal apps automatically prove their identity and earn trust. In practice, PKI makes sure you're really talking to the right system before any encryption starts. The server presents a certificate, your device checks that certificate against trusted certificate authorities, and only if that chain is valid does TLS create an encrypted session. That same pattern protects HTTPS, internal web apps, RDP, VPNs, and service-to-service APIs. In many enterprises, Microsoft ADCS issues the internal certificates that power all of this. Encryption focuses on keeping data private. Digital signatures solve a different problem. They let us detect any change and prove who signed something. When you sign code, an email, or a document with a certificate, you're attaching a verifiable fingerprint of the content plus your identity. That trust only holds if the certificate is legitimate. It chains to a trusted authority, is not expired or revoked, and is allowed for signing. Consider a simple HR portal, like https://hr.contoso.local. To be trusted, its TLS certificate must come from a CA that your users' devices already trust. For public sites, that's a public CA built into the browser. For internal apps, it's usually an enterprise CA. The certificate's names must match the DNS names users type. If they don't, you get browser warnings, broken APIs, and users learning to ignore real security problems. Remote desktop with self-signed certificates constantly shows warnings. Over time, admins click through automatically, which defeats the purpose of the warning and opens the door to spoofed servers. By issuing RDP certificates from ADCS, each server presents a certificate that chains to a trusted root and matches the server name admins actually use. Combined with group policy deployment, you get silent, trusted connections, and any unexpected prompt becomes a real red flag. Certificates let both users and devices prove who they are without depending on passwords. User certificates support strong logon, secure email, and access decisions tied to identity. Computer certificates let domain services, VPNs, Wi-Fi, and management tools trust the device itself. Auto-enrollment handles the heavy lifting, pushing the right certificates to the right accounts using Active Directory and group policy. That's why careful template design and EKU choices are critical for overall domain security. Once your PKI is in place, it becomes a security Swiss Army knife. S-MIME certificates let users sign and encrypt email, proving who sent it and protecting content. VPN and Wi-Fi certificates authenticate users or devices before they ever reach the network. Code signing certificates prove software came from you and hasn't been modified. Each scenario depends on correct certificate purposes, templates, and issuance policies. Microsoft ADCS really shines when it's tightly integrated with Active Directory. The Enterprise CA issues certificates based on templates, which define who can enroll and what each certificate is allowed to do. Group policy then pushes trust and auto-enrollment settings out to domain machines, so certificates appear and renew automatically. Those certificates live in the Windows certificate stores, while ADCS tracks the whole lifecycle: issuance, renewal, revocation, and recovery. You now have a working mental model for PKI. Certificates solve trust problems, represent identities, encrypt data, sign content, and authenticate machines at scale. ADCS is your enterprise engine for issuing and managing those certificates. With this foundation in place, you're ready to move into cryptography basics for PKI.